ready? Here is the recording for chapter 8-9, lesson 5. And just remember, a reminder, this is the last lesson of this unit, and you are going to be having your quiz next week, okay? So just a reminder that yesterday we solved a system of equations graphically. So for example, yesterday we maybe drew a parabola, and then we drew maybe a linear function through it, and then we stated the 2 points where it would cross. Sometimes there's no solution, sometimes there's only one solution, sometimes there are two solutions. So we actually graphed them out to see where the two graphs would cross. Now, today we are going to be doing the same thing. We're going to be solving these systems, finding the solution. However, we're going to do it algebraically. So we're not graphing anymore. We're just using good old algebra, and we are going to be doing something called the elimination method. Now, you actually did the elimination back in Foundations 10. So this might come back to you a little bit as we're doing it. But what's obviously more difficult with these ones is we have quadratics involved, whereas in Foundations 10, you only had two linear functions. So here are some steps that we're going to follow every single time. So first thing first, we're going to isolate y in each equation. No big deal. We've done that a million times. Number 2 is we are going to subtract the second equation from the first one. So we're going to find the difference between the two equations. And the reason we do that is by doing this, the y value should cancel out, right? Like if we have isolated y in both equations and we minus them, I would have y minus y. It would be totally gone. So that's good because then we would only have an x value and we could solve for x. So that's our next step. Step 3, we would solve for x. Now, to solve for x, we either have to factor, which we're so used to, or use the quadratic formula, or if you really like completing the square, be my guest. But just remember, when you're completing the square, you have to make sure your a value is 1. Some of you forget that, okay? But you can also just factor or use the quadratic formula for sure. Then that will help us find x, but now we need to find y. So once we find x in step 3, we take those x values, we sub them back in to find y. Okay, and then step number 5 is verifying, which is going to be optional. I'm going to show you how to verify the first one, but then beyond that, I'm not going to show you again. You can do that on your own if you want. Okay, so here we go. Here's my two equations. So I know here that this is a quadratic and then a linear function, okay? And step number 1 said to isolate y in both equations. Well, they are already isolated, no problem, okay? I'm just gonna label this equation number 1 and this equation number 2, just so you know which one I'm talking about as I go through. Okay, so step number 1 is done. I've isolated y in each equation. Now, step number 2 is subtracting them. So I literally write a subtraction symbol and my equal to sign. So we kind of have like a stacked subtraction. Now I'm going to subtract each term. So y minus y on the left-hand side here will result in 0. It's totally gone. Now, here you got to be careful. My next term is x squared. I then minus off no other x squared, right? No x squared exists in this guy. So I am not minusing anything off. So x squared minus nothing will just stay an x squared. Okay, then I go to my next term, which is a negative x. And this is where we have to be careful because I have a negative 1x. And then I want to minus off a 1x. So negative 1 minus 1 is negative 2. I have negative 2 x's now. And then again, I repeat the process with my final term, negative 6 minus negative 3. So be careful with your symbols. I've got the negative 6. I am minusing off a negative 3. So I actually have negative 6 plus 3. So I have a minus 3. Okay, so we have minus the 2. We've cleaned up our terms. All is well. I have this nice trinomial, and I'm going to cross my fingers that I can factor it. Okay, I have an a value of 1, so this should be quite simple if I can factor it. What two numbers multiply to 3 and add or subtract for negative 2? It would be 3 and 1. And to get my symbols right, I would need a -3 and I would have to add 1. Okay, so this tells me that I'm going to have two solutions because I have x equals 3 as my first solution and x equals -1 as my second solution. So that tells me that this system, if I were to graph it out, I would be crossing at 2 locations. But as I've said before, your x value is only half the battle. We now need to find our y value for the coordinate, right? We need the points. So now I am at step number 4. Step number 4 is to substitute each answer for x into one of the original equations. So it does not matter which of these two equations you plug into, it will give you the same answer. So I always recommend choosing the simpler one, which to me looks like number 2. So I'm going to sub my first answer for x, which is 3, into equation number 2. Alrighty, so I have y equals x, which is 3 minus 3. And so I have y equaling 0. So I just found that my first point, my first solution, when x is 3, y is 0, and that is one of your solutions. Now you have to repeat the process. You can sub it into the exact same one again. So, but this time I switched to my other value that I found of -1, and I'm going to sub that into the easier of the two equations. But by all means, if you sub it into equation 1, you'll get the same answer. Okay, so this time I would have y equals -1 is my x value, and I am minusing 3. -1 minus 3 is -4. So when x is -1, y is -4. There's your second answer. Okay, solution set, list them. There we go. Okay, and I'm very quickly going to show you how to verify, but you don't have to do this all the time for me. Okay, well, that's too thick. No, thank you. All right, so if I want to verify the first answer I got of 3, 0, okay, you're going to plug both values into the equations just to make sure they balance. Okay, so if I plug them in, if I plug them into equation 1, I would have y equals, so 0 equals, and then equation 1 gives me an x squared, so 3 squared minus x, so minus 3 minus 6. Don't move stuff around, just clean up your right side. 9 minus 3 minus 6 is 0. Okay, so just to save on time today, I'm not going to show you all of them, but you would just repeat the process and sub 3 and 0 into the next one, equation 2, and you would get it again. And then you would repeat the process for your other point. And this is what I'm not going to show you just to save on time for this video, but you would just repeat the exact same process by plugging this x and this y into your two equations. And they do balance. I've checked it, so we know that those answers are correct. Okay, moving on. So this one is a bit more complicated because you can see my y's are not isolated. So I have some work to do. So step number 1 says isolate your y. So again, I'm going to call this equation 1 and this equation 2. Okay, so I'm going to start with equation 1. If I am isolating y in equation number 1, I want to send over those two terms. And then I'm going to also want to divide off this negative in the end. So I have a little bit of work to do. So I'm going to do that right here. I'm going to do the first step right here. I would have -y all by itself on the left. Then the x squared comes to the right and becomes negative. The negative x comes to the other side and becomes positive. And then that +6 just gets shoved down, but it stays positive. All right, divide everything by -1 all across the board. All of your symbols change. So this is your new equation number 1. I repeat the process with this guy. The -y is on the left. I send over the 2x. I'm going to put that in front. And it becomes a -2x. And I shove down that 2. And then final step, I divide everything by a -1. And there's your new equation number 2. Okay, so what I'm going to do is I'm going to go over here. I'm going to restack them. So I'm going to take these nice cleaned up equations. I'm going to restack them and I'm going to subtract them. All right. So remember, the point of isolating y was so that when you went y minus y, you got 0. Great. I recopy the equal sign. Okay. Similar to the previous question, I have an x squared, but I'm not minusing off any other x squareds. So x squared minus nothing is just x squared. Okay. Then I move on to my negative 1x. I have negative 1x minus 2x. So just kind of remember that you have brackets around this and you have to kind of distribute this negative in, right? You can't forget about that. So negative 1 minus 2 is negative 3x. And finally, my final term is negative 6. Stop here, minus, and then a negative 2. So it's actually negative 6 plus 2. So you actually have minus 4. Okay, there's your nice new trinomial. You only have x left, which means you can hopefully solve for x. I can factor that because I can see I can use the factors of 4 and 1. So I have x and 4, x and 1. To get my symbols working out for me, I want to have a negative 4 and then add 1. That gives me the negative 3. So once again, I have two solutions. X equals positive 4 and x equals negative 1 when you set those equal to 0 and solve. Okay, so just like the previous question, once you have your two answers or one answer or however many answers, you sub those into one of the original equations, okay, to find the other half, right? You have to find your y value now. Now, I would recommend still plugging it into one of the originals. Okay, the reason why is because you might have made a mistake with one of these two, right? Like you guys might have had a symbol wrong by accident because you guys did the work to like isolate y in these. Whereas we know that the two original ones are typed out and they're perfect. There's no errors in them. So that's why I recommend plugging them into one of your originals just to really make sure we're plugging it into the right equation with no mistakes in it. So the first thing I'm going to do is I'm going to sub x equals 4, my first answer. I'll sub that into the one that looks easier again, so number 2 again. Okay, and I'm going to plug it into the original number 2, which means I have 2 times 4 minus y equals 2. I have 8 minus y equals 2. Solve this however you see fit. I'm going to minus 8 to both sides to get negative y equals negative 6. If I divide by negative 1, I get that y is 6. So my first point, when x is 4, y is 6. That's my first solution. Now I repeat the process. I'm going to sub my other x value of negative 1 just to show you how to use the other equation. I'm going to plug it into number 1, but again, you could use number 2 because it does look easier. But if I plug x equals negative 1 into equation number 1, I would have negative 1 squared. Make sure you put that negative 1 in brackets because you have to square the negative also. So that's actually going to end up being positive 1. Then I am minusing off a negative 1. Then I am minusing y equaling 6. So that looks kind of ugly. Let's clean up our symbols. Negative 1 in brackets squared is positive 1. Then that's going to end up being plus 1 minus y equals 6. Okay, I have 2 minus y equals 6. I'm going to minus 2 to both sides. I have negative y equals 4. And I divide off the negative 1. And I get an answer of negative 4. So I just figured out my second point. When x is negative 1, y is negative 4. And had you plugged it into the other equation, it would have given you the same answer. Okay. My two solutions in my solution set. Verify if you want. Call it a day. Okay. Next example. So, sorry, these are really spread out for some reason, the way that OneNote worked. So I'm just going to rewrite this guy up top here. Ignore that. Okay, so I have two parabolas here again. Let's see if they cross once or twice or not at all. Nice for us, the y's are already isolated, so I can just begin right away by subtracting. So my y is now eliminated. That is why it is called the elimination method. Y is gone. Okay, again, try to remember that this is in brackets. This negative has to be kind of sent in, and you can do that in your head. You have 2x squared minus a negative x squared. So really you have 2x squared plus x squared. You have 3x squared. On to the next. Negative 7x minus, always stop here, positive 6. That's actually negative 7 minus 6. That's negative 13x. And 3 minus a negative 7 is actually 3 plus 7. You've got a positive 10. Okay, so this is what Miss Marchand calls a hard to give you, right? So my A is not 1, so we're going to do guess and check. Let's see if we can get our factors. So the two numbers that multiply to give us 3, there's only one option, so no guessing involved. It has to be that. And then two numbers that multiply for 10. Well, 1 and 10 or 5 and 2. Remember me saying it's usually not the one with the 1. So we would try 5 and 2 here. And I actually want to show you something very interesting. If we put the 5 here and the 2 here, a lot of students think they've nailed it because they go, well, that's 5x, that's 10 or 6, sorry. I put those in the wrong spot. Sorry, that one doesn't work. I'm thinking of the other one. 3x, x. If I use 5 and 2 and I put the 5 here, pardon me. If I do that, is that what I just had? I'm losing my mind. Okay, if I do that, that's 2x. And if I do that, here we go. Yeah, that's 15x. So students think they've nailed it because I always ask at this point, can a 2 and a 15 give us a negative 13? And we would say, yeah, they can if you make the 2 positive and the 15 negative. That would give you negative 13x, our middle term. So we think life is good. So we put a positive there and we put a negative there. But the problem is I want my result to be positive 10. And a positive 2 and a negative 5 give me a negative 10. So actually, because of that one little symbol, this is not going to work. Symbols matter. So, hate to break it to you, you got to erase everything we just did. And we are actually going to try the 10 and the 1. I know I usually say it's not the one with the, usually not the one with the 1, but here's an odd case where it is. So if I put the 10 there and the 1 there, I have 10x, I have 3x. Can those give me a 13? Yes, they can. If they're both negative, there we go. Those would give us a positive 10. Okay, that's not a very fun one. My apologies. So my first solution, if I send 10 over to the other side, it becomes positive. And if I divide by 3, I get my first solution of 10 over 3. So to set that equal to 0 and solve. Same thing here, x equals 1. Okay, we have fractions. We love fractions. Alrighty, next step is to take your first answer you just got, 10 over 3. Don't you dare change that to a decimal. That decimal is 3.333333. You don't get to use that. You have to use the exact value. So 10 over 3, we're going to sub that into whichever one looks easier. I would say both those equations look pretty much the same. I'm going to plug it into number 1. Okay, so y will equal 2 bracket 10 over 3 squared minus 7 times 10 over 3 plus 3. Square first. 100 over 9 minus 70 over 3 plus 3. So just some basic math there. I squared that first fraction, and then the second fraction, 7 times 10, got me that 70. Alrighty, now I have 200 over 9 minus, you know what I'm going to do? You know what I'm going to do? I'm going to do that right now because I know I'm going to have them both over 9, right? So if I go times 3, I have 210 over 9. And you know what I'm going to do? I'm going to put that over 1. I'm going to do the same thing. I'm going to change that to a 9 also. And I therefore have 27 over 9. Okay, common denominators means you can do all the tops together. So 200 minus 210 is negative 10. Negative 10 plus 27 is positive 17 over 9. So you just found your first point. It's nasty, but when x is 10 over 3 and y is 17 over 9, those two graphs will cross. Okay, this one will be nicer because the answer is just 1. Oops. I'm going to sub x equals 1 into, let's be crazy, let's sub it into 2 this time. Okay, if I sub it into equation number 2, that's negative, and then the x is just 1 squared, so that negative is on the outside of the bracket. Okay, plus 6 times 1 minus 7, that is negative 1 plus 6 minus 7, that is 2. Negative 2, sorry. Negative 2. And so when x is 1, y is negative 2. There are your two solutions. That fraction was a little bit nasty, but that's life. You're going to see some of those, okay? You're going to have to find common denominators and all that. No decimals. Okie doke. Last one. Oh boy. Okay, so now I give you a fraction within the equation itself. Okay, that's okay. We'll survive. Step number 1 is to isolate y. So I can see the only guy bothering me is that guy right there. So I just have to send him over. So instead of rewriting absolutely everything, you can just cross it off and go plus 1. That's an option. Or you are allowed to turn this into equation 1, bring him underneath, and rewrite him if you want underneath with the plus 1 over there. It doesn't matter. You can turn equation 1 into equation 2. It doesn't matter as long as you have two equations, both isolated for y, stacked on top of each other. It should work. So we slap our big fat minus and we subtract. Okay. So I have negative 3x squared minus, and then I have no other x squared term. So nothing changes. I have 0 equals negative 3x squared. Okay, next I have a problem. I have a positive 8, right, x, and then I am minusing off this negative 7 over 8x. I can't do that in my head. So if you need to go off to the side and do that, by all means, or you are allowed to physically just write it out. We know we're going to have to do positive 8 plus 7 over 8. And so we'll just do it in the midst of the equation. We'll have one extra step to do down here, but that's okay because I can't do that in my head, or do it off to the side, no problem. And then my last one is negative 1 minus 1. That gives me negative 2. Okay, so before I can figure out if I can factor this or not, I have to simplify these. I want it to be a trinomial. So this is over 1. I'm going to go times 8 times 8. So I actually have negative 3x squared and then a positive 64 over 8x plus 7 over 8x minus 2. Now I can add those. 64 plus 7 is 71 minus 2. Okay, so here we are. I don't know about you, but I really don't want to even try to factor that right now with the fraction. We don't like fractions. So if we can get rid of a fraction, we must to make our life easier. If I go across the equation and multiply everything by 8, I'm being totally fair. I'm multiplying everything on my left by 8, everything on my right by 8. So I'm allowed to do that. That's not a problem. And what happens is my left side remains 0, so that's nice. The 3 becomes a negative 24. The 71 over 8 just becomes a 71 because the 8's cancel, and then that becomes a negative 16. Okay, so that's what we have. Now, If you want to try to factor that, I would highly recommend first dividing out that negative, right? We don't like that guy. I'll tell you right now that you can't factor it. Even if you tried to take the negative out and we did guess and check, we're not going to be able to. So when you can't factor it, the next step is the quadratic formula. So this is my A value. This is my B value, and this is my C value. I feel like we haven't done the quadratic formula in a while. So x equals negative b plus or minus square root b squared minus 4 times a times c. Make sure you get all your symbols in there, all over 2a. Okie doke. Calculators are your friend here. I have negative 71 plus or minus. All right, 71 squared is 5,041. Now, you know this frustrates me. You have a negative, and a negative that follow. Ask yourself, does 3 negatives become a negative or does it become a positive? And I hope you answer that it becomes a negative. 2 will cancel out, so there's 1 remaining. You gotta be careful with that symbol, okay? And then 4 times 24 times 16 is 1536, and that is all over negative 48. Okay, I have negative 71 plus or minus. My radical becomes 3505. And there we are. Now, we are essentially trying to find points, right? Like in theory, we're graphing this behind the scenes. We could be graphing this. And you know me, when we're graphing, I allow decimals to plot points. It's hard to plot that point, right? Gross. So you can change this to a decimal. So option number 1 is negative 71 plus 59.2 over negative 48. Or it's negative 71 minus 59.2 over negative 48. Okie doke. So when you get the help of your calculator and figure that all out, that is going to give you a 2.7-ish, 2.71. And then when you do this one, when you give this, sorry, I had a brain fart, 0.25. Okay, so those are our x values. So again, we see that we have 2 x values. That means we're crossing at 2 locations, but we've only done half the battle. Now we have to plug in to find our other half, the y values. Okay, so I'm going to take the first x I got, which is 2.7, and I'm going to sub that into the easier looking equation. I would say they're equally annoying. The first one has a fraction, the second one has a square. I'm going to go into number 2. But you do you. All right, y equals negative 3. Open up that bracket. I have a 2.7 squared plus 8 times 2.7 minus 1. Okay. This is kind of a long lesson, so to save time right here, I am going to just tell you what the answer is. And actually, on my sheet, I plugged it into equation 1. I should have been paying attention. If you plug this into equation 2, though, you should get an approximate y value of about negative 1.36-ish or 37-ish, depending on if you use 2.7 or 2.71. Okay? I believe it's negative 1.37. All right, so there is your first value, 2.7, negative 1.37, or negative 1.4. That's okay. Okay, and then sub your second one. We're almost there. My second value is 0.25. I'm going to plug this into 1 this time, just to be a little bit crazy. Y equals, or sorry, it's not y equals. The first equation is y minus 1 first. Remember, I told you to plug it into the original. So that's what plugging into number 1 original would look like. Okay, I do have to add 1 to both sides. So I would have y equals. Now, just do this on your calculator. Go negative 7 divided by 8. Get that answer, times it by 0.25, and then add 1, and you should get a final answer of about 0.78. So my final answer here is 0.25 and 0.78. Slap those in a solution set and call it a day. So I know we're not graphing today, which is nice. However, you can see that sometimes these questions get a little bit wild. Okay, I wouldn't say it's necessarily easy or harder. It's just very, very different. Okay, now your assignment is only 2 questions from the textbook. It does say to do substitution method. I want you to ignore that. I want you to do the elimination method that we just did for both questions 3 and 4. Okay, remember you guys have your assignment from yesterday to work on as well. That's that worksheet where you have to graph the equations. Okay, I will see you tomorrow. Get to work and be good.